Okay. What's the
So
time?
Paul McPherson, are you in isolation? Are you in the third ring of contacts in Shepparton?
No, no, we've got people going all over the place, Rod.
Yeah.
And my dear old mum's been in lockdown since yesterday afternoon, and we can't go to see her anymore. So, and going by news, this chap who's not going to be charged with any offence after putting Kilmore, and probably not so much Benalla, but certainly Shep's just gone into lockdown. Thousands of people being killed.
Yeah.
On a serious note, if I can talk through Terry here, is while we're waiting to start.
Yeah.
It does bring up an interesting thing. Apparently, New South Wales have had this third ring. You know, like you've got someone who's positive, then you've got close contacts, then you've got contacts again, which just blows it into large numbers. Does anyone else think, my gosh, I look at my friends and think, you know, I mean, does it make you want to think, I don't know how much I want to actually socialise? Because you can get caught into an isolation situation very, very easily from a friend who's inadvertently got a friend who's tested positive. It's quite amazing. It's quite amazing. It just boggles my mind tonight to think of, you know, do you actually just go down and even sit in the park with a couple you know well, then they're caught in this and you're caught by the next level.
Yeah, but that's how Bill and Jenny Metcalf got caught, you know.
That's right. But Bill actually caught it, but some of us could actually, and that's what's happened to Shep. There's 400 or 500 people in isolation tonight.
Yeah.
You know, even because they're only closer contacts to people that got crook in the cafe, the barber shop, and
Bill Metcalf told me he was actually in hospital for 12 days.
Yeah.
12 days with it. So, you know, and Jeannie got it too, and their son.
Some people
Anyway.
don't get over it very well either.
No. Well, no, they say
Some are lucky, some aren't.
you can have some repercussions after it. Yeah.
Particularly
What sort of repercussions?
Problems.
Oh, well, all sorts of organ failure, long-term lungs, obviously, but they're just, my daughter's a doctor in Beechworth, and she said that we haven't even been told properly that they're aware of it now. They're already seeing it from those who've recovered from earlier. Yeah. It could be liver, it could be heart, it can be respiratory, it can be anything. Yeah. It's not everybody, once again, but you get over it. You're not necessarily over it if you're one of the unlucky ones.
No, and I think that's where the older ones are so much more vulnerable. I mean, both my son and his wife both got it in Sydney very, very early, and they haven't had any problems since. But they're only in their 30s, you know. So
it's lucky we're not in that old age group, so we'll be okay.
Just have a look around the screen.
Yeah. Good point. Okay, well, I think it's 8 o'clock, 8:01. Might just wait a couple more minutes and see if we can get anyone else on board. I would have hoped this presentation tonight, I'll tell you a little bit about it while we're waiting. We actually borrowed it from the Sprite Club. The Sprite Club, one of their members is a bit of I think he's a bit like our Gordon. He searches for all sorts of stuff, and he found this couple that were building an electric motorcycle. Now that sounds pretty, you know, pretty weird really, but they have been doing on this thing for a few years, and they were wanting to try and get their electric motorcycle. They're originally from America. They moved to New Zealand, and they are in New Zealand now. So this presentation that we're showing tonight is from them in New Zealand. And they built this electric motorcycle, and they wanted to achieve the world record for electric motorcycles, which is about 400 kilometres an hour. And so when they built the motorcycle, they transported it here to Australia just before Christmas or just after Christmas, and they were going to go to Lake Gairdner and hopefully set the world record at Lake Gairdner. But of course, that all went pear-shaped because Lake Gedney got cancelled.
Yeah.
And so they finished up having to ship the motorcycle back to New Zealand. And I don't quite know where it goes from there, whether they're intending to try and come back next year or what their plan is. But I've seen it, this presentation. They're an interesting couple. She's comes from, and I forget where, but she's a bit hard to understand at times. He's American, so he's quite easy to understand. I think she comes from somewhere like a European country somewhere. They're both engineers, and they met through their love of wanting to break land speed records, and so they've hooked up together, and they're living in New Zealand at the moment. And I don't quite know what they're going to do next, but it's a good presentation, and I must thank the Sprite Club for letting us use it. I saw it originally at the Sprite Club meeting where they showed it, and at the time I thought this would interest a lot of people, because they have gone to a lot of trouble and have spent quite a few years on this project, and just when they thought they were able to take it to Lake Gedney, it all got canned. So I think we'll start, Gordon, and anyone that comes in can join in anyway.
Terry, just as a side on the electric motorbikes, I saw them at the Isle of Man a couple of years ago, and it's an unreal experience. First of all, you don't hear them coming, so before you know it, they've gone past you. The track there, as everyone knows, is best part of 40 miles, and they could only do one lap because that's the size of the battery that would see through. It was a really unbelievable to see this motorbike going through quite quick, but no sound. It was just unreal.
You want another story about electric motorbikes?
Yeah, sure.
It's a rather strange one. When I was working, we used to subcontract quite a bit of work to a very smart engineer, and he took on some crazy projects, absolutely mental projects that we wouldn't touch with a barge pole. Anyway, one day he said, I've got an order to develop an electric motorbike. And we said, oh, okay, well, who's this? He said, oh, it's some young guy. He wants me to develop it for him. And this guy that we used to subcontract had a history of taking ridiculous projects that lost him a lot of money. So I said to him, well, okay, Rick, how's this guy going to pay for it? And he said, oh, there's no problem with him paying. He said his girlfriend is a pole dancer, and she will give me the earnings from 1 day a week. So he's giving me $1,000 a week. So where can I get a girlfriend like that?
Can we have a definition of pole dancing, please?
I don't know. I wasn't sure what it was.
So Alan, was she a good pole dancer, Alan? You obviously had to go.
I kept well clear of it. I don't like jobs like that.
Oh, you just took him in his word. All right, okay.
Okay, we've got a couple more joined in, so I think we'll start, Gordon, and I'll leave it to you.
I'll mute everybody, so if you want to make a bit of noise in the background, you can.
I won't say any more than that because I don't want to steal their thunder. Welcome very much, Eva and Bill. It's a real pleasure and a privilege to have you as our guests. Thank you for staying up late. And I'll hand over to you.
All right, thank you so much. We are nocturnal people.
Yeah, we're night owls.
So this is not very late for us at all. Anyway, so I'm Eva.
I'm Bill.
Bill is my trophy husband since 11 years back.
I don't know what she was competing for. Yeah.
And we are basically co-addicts in electric racing.
We are.
That's the only way of describing it. So I will see if the miracles of internet works here, so I can share my screen. No, host has disabled
our screen sharing.
Just a
that screen.
There we go.
Can you see our screen? Yes?
Yeah,
Okay, I get thumbs up there. Great. All of you kind of disappeared in here, but that's all right. So we are invited because we have a pretty cool hobby, I would say. So our addiction in life is to build the world's fastest electric motorcycles. So what you see here is the Kilojoule, which is our first Streamliner motorcycle we built, and which is now retired and replaced with Green Envy, as Gary mentioned. And if we somehow disappear with audio and such, I hope someone lets us know, or if something doesn't work here. So Bill and I have been into electric racing since before electric vehicles were cool. Bill built his first electric car in 1995?
Yeah, something like that.
I built my first electric motorcycle early 2000s, but my dad has been into electric since the first oil crisis in the 1970s. So this is all a genetic disorder from my point. So the title of our little presentation here is Saving the Planet at 400 kilometers per hour. We will get to why that is in just a little bit, because saving the planet, eco-friendly, and speed typically doesn't go together, but we think it should. So building a vehicle like this is a big project, like every hobby motorcycle or hobby car is. So another suitable title could have been How to Run a Large Project on a Shoestring Budget, because what we do is really way over our resources. And if you are short on money, you have to be long on clever. And I guess that's our...
Yeah, like most addicts, we are addicted, and
scrambling to keep our habits going.
Yeah, and it just eats everything. Yeah.
So the Kilojoule is currently the world's fastest electric motorcycle, and we'd just like to put that in a perspective, because lots of people talk about being the fastest, and there are many fastest vehicles. So if you look on a little bit of a scale, we are here at about 400 kilometers per hour. That's just a tiny bit slower than the world's fastest production car, if you now can think of these very low series cars as production cars, but that's what they claim.
I think it costs about the same as the Kilojoule, maybe more.
Oh, it costs way more. Oh yeah, that's Koenigsegg, I don't know, $1 million maybe?
Okay.
Something like that. Even if that's the fastest production car, that's a whole lot slower than the fastest wheel-driven car, which is over, actually posted speeds over 800 kilometers per hour.
Recently.
A lot faster than your typical family car. My Nissan Leaf wouldn't even do that kind of speed, but it takes me where I need to go. And if we just look a little bit historically, in 1889, the fastest car in the world was actually electric. And since then, internal combustion has completely dominated everything.
Well, we had the sidecar record briefly.
Okay, I guess that's true. For a very brief moment, for a couple of years,
right.
The Kilojoule was also the world's fastest sidecar motorcycles.
Full stop.
Full stop.
Yeah, we had it. And then they figured out what we were doing. And then now
someone took that away. So records are never owned. They are only borrowed for longer or shorter time. We are still quite slow compared to the world's fastest electric car, which is about 550 kilometers per hour, which is also slow compared to the world's fastest motorcycle at 640. All of these are quite slow compared to the world's fastest car overall, which has gone supersonic, which again is slow compared to the latest, which is British, nicely enough, the Bloodhound that's shooting for 1,000 miles per hour. So that's a little bit of perspective where we are, and you can see there is lots of room for improvement in speeds. All right, so that's kind of where we are and what we're doing. So when we started building the Kilojoule, we had a dream but it was actually not about speed, even if that may sound strange. So I am a tree hugger at heart. Bill is kind of a tree hugger.
I like trees.
You like trees. I'm the real tree hugger.
Yeah, I don't hug them.
And I just kind of always been this way of I want to save the planet, but I also like fast vehicles and engineering and how do we combine the two.
As am I.
So our dream was actually to make people understand that electric cars are great. You can tell a joke here about British cars. British.
Can I? Okay.
Yeah, I think you can.
Yeah.
It's a suitable joke.
The reason the Brits haven't come out with an electric car these days is because they haven't discovered how to make them leak oil in the proper manner.
And they're far away enough so they can't hit us.
No, they can't hit us. Yeah, that's it.
Anyway, our dream was to promote electric vehicles, and this was way before Elon Musk and Tesla and all these sexy electric cars. This was a time when electric cars was considered boring, slow, and something that would never, ever catch on.
Golf carts.
It was golf carts, basically. But we knew the potential of electric cars, and we knew it also is a perfect match with renewable energy. This is our house we still own in Colorado, where we actually made our own fuel. We bought in the Nissan Leaf, we bought solar panels, and we actually never bought any fuel more. And again, ever again. And our goal was to build something that was so insanely fast that it would make headlines and get people interested. And I just want to double check. You see our screen, right? You see the PowerPoint?
Yeah, it's fine, Eva.
Good, good, because we can't see it here in our Zoom version.
Sure.
So the idea was something that's super fast, make turn heads, make headlines, and also it had to be sexy. So that's me. I clean up pretty well, and it's not my standard outfit, but it is indeed me. Because buying a car, we think it's a rational purchase, but it's not. Or we all buy cars based on emotions.
Your emotions make you buy a car.
So we realized if we're going to build something to change people's minds, it has to be fast, it has to be cool, it has to be sexy. And I came up with my own term for this. I call it eco-activism in disguise. So I've always been kind of a tree hugger, always been into environmental work. I had friends who became Greenpeace activists. I admire their work, but I didn't like the idea of getting arrested. So I thought I need to find another way of doing something, promoting eco-friendly technology. So this was my way. And at 434 kilometers per hour so far, we are certainly getting people's attention. I might just say a few words if you wonder where my very strange accent comes from. I'm originally from Sweden, moved to Colorado 13 years ago for love.
And I'm from the East Coast, so it influences their speech.
So I have an East Coast, Colorado, Swedish, New Zealand accent. So that's, and we met through electric vehicles.
Yeah.
I can get into that later on if someone is interested in a bit of history. So how do you make a plan like this become reality? So we set a goal to build the world's fastest electric motorcycle, which was quite a big goal. And I was in engineering school at the time. And you know, you have so much time and money when you're in school that you need a solid hobby project. Of course, that's a joke. You have absolutely no life outside school when you're studying to an engineer.
Yeah.
But I had a husband who collected a pretty good engineer's salary. And together with a lot of cleverness and volunteers, we actually turned this into reality. And the reason we could do that is we had a great team. I think I had the best teammates.
Yeah.
And we're both mechanical engineers, by the way. And we also have had great volunteers. We've had many volunteers over the years, contributed to different parts of the project. These were the people that made their way all the way out to the Australian outbacks to help us there.
That is a chore to get out there. You know, dedication.
You know exactly what the Australian outbacks is, and that is definitely dedication to make it all the way out to Lake Gabriel.
Yeah.
So we had a team, we had volunteers, and we had a headquarters. So this is the headquarters in Colorado, aka our 2-car garage, and that is where the kilojoule was built. And it is the size it is because it was the longest thing we could fit in the garage, and it was the longest vehicle we could fit in our existing trailer.
That's exactly right.
And when you work on a budget, you start looking at what your limitations are, and that's where we started. So in 2009, the concept of the kilojoule was born. I guess this is the equivalent of a sonogram for a racing vehicle. This is the very first, first early CAD. And then being on a budget, we bought a $750 Craigslist motorcycle. Craigslist is equivalent to Trade Me or the local eBay marketplace. We never even started it because we didn't care if it ran or not. We wanted the brakes, we wanted the wheels, because buying new brakes and wheels was way outside our budget.
And this was cheap.
So we bought this one. So we had this totally naive idea that we were going to build a streamliner for $10,000 in a year. And we ended up, well, we still not done yet, but the kilojoule, we spent 9 years on it, and
I don't even want to think. I can't, it just consumes.
We would have owned a Tesla if we
two
if we hadn't built this. Yeah. Anyway, we bought this motorcycle. We called in our friends, say, let's come and help us build a streamliner. It will be fun, particularly in March in Colorado looks like this. and this is Clay who helped us weld the frame on the kilojoule. The first frame. He drove up from California, sunny California, to Colorado in his van with his welding equipment. And this is what met him.
And his uncle.
That's right. He grabbed his uncle. Wonderful couple of people.
Yeah. Kind of like Bert and Ernie, actually.
A little bit like Bert and Ernie.
Yeah.
I don't know if we have a picture of Gary in here. Yeah, that's the uncle's name. Anyway, we spent a week cutting away, bending, working, grinding, and a week later, or about 5 days later, we had, there he is.
Yeah.
And we had first chassis.
Yeah.
So here's my very first test ride, and we thought, oh, we are almost done. We built the streamliner in 5 days.
Yeah.
And then, okay, this one has to be covered in body work, and a fiberglass body of this size is about some $30,000, $40,000, $50,000 or so. Didn't fit in that $10,000 budget, so I thought, it's about round on the nose, and then it's pretty much straight in the back, like a toothpaste tube. So I bought myself a Pilates ball, and then I stretched my composite skills and made a nose cone. And somewhere along the way, I ran out of volunteers, so I recruited my mom, who was foolish enough to visit me in Colorado. So she was put to work. She's a mechanical engineer as well.
Yeah.
But she claims.
Oh, the statute of limitations ran out a number of years ago. She doesn't do it anymore. Everyone in her family is an engineer. Her brothers, her father, her mother, everyone. So it's a genetic disorder.
It's definitely a genetic disorder. So this was April. Race was scheduled for September. In August, we had 1 month left before we were leaving to Bonneville. By the way, we had never been to Bonneville. We just thought, let's build a streamliner motorcycle because we want to set a speed record. And if you want to go really fast, you have to build some sort of streamlined vehicle. That will always beat the open vehicles. And we settled for a motorcycle because you get a whole lot more speed for your money in a smaller vehicle. Also, we couldn't fit a car in the trailer either.
Right.
So we settled for a fully enclosed streamlined motorcycle. What we didn't know at the time is that the motorcycles come in 2 versions. They come as 2-wheelers, so solo motorcycles, or they come as sidecar motorcycles. So the kilojoule was built as a 2-wheeled motorcycle. So 1 month left to the first race. 2 weeks to the first race was the first time we had it running. So this was an early Sunday morning. It's a good way of meeting your neighbors. You can drive around the block. And you can see here, it has a little landing gear, a pneumatically actuated landing gear for low speed. I drove around the block, and 2 weeks before our first race, this kind of summarizes my whole feeling, realizing there's no way ever I can drive this thing on 2 wheels.
Can't balance it.
It can't balance it. I could barely steer it. I couldn't balance it. But, you know, show must go on. We had a race to go to. We were committed. So we continued. 4 days before the first race, we still didn't finish the bodywork.
All right.
I wanted to throw in the towel.
No.
Bill said, no, we are committed. We are going.
All right.
And we took this pre-painted sign stock. So this is an aluminum panel who is pre-painted red on one side, white on the other side, and has protective plastics on it. Bent it over the knee, taped it down, screwed it, and
Clecoed it into position.
Cleco into position. You can also see, if you look on the side, you can see all the lead ballast bolted to the frame because he wanted to tilt over to the, fall over to the right all the time. And we added all lead we could find in an attempt to try to get it upright, but I kind of knew at this point there was no hope, but on the other hand, there was no choice either. So we finally left 1 day later than we should have,
Right.
but it was
1 day late.
1 day late, and it was kind of finished. We showed up to Bonneville. We made it there with something that looked like a streamliner. Everything ran great except, as I had suspected, I could absolutely not balance it on 2 wheels.
Steering was really poor. She had a limited range to steering and not much leverage. It was not good.
It was also about half a meter too short in the driver's compartment.
Yes, all of the above.
So, but we learned a lot, and the most important thing we learned is that there is a category for sidecar streamliner motorcycles, which is philosophically what I say, an asymmetric car. But it has an extra wheel, it has a third wheel, it drives like a car, but still qualifies as a motorcycle. Sorry.
And has the same frontal area pretty much as a motorcycle.
So we came back a year later
with a sidecar.
With a sidecar. And this is a bit of a funny story. I posted this picture on Facebook, and basically from the sky just fell a new volunteer. I got a message from someone I'd never met before, but he makes a living out of building composites parts for airplanes. And he said, I saw your picture on Facebook. You need help. Let me help you. Basically, this looks like crap. You're an embarrassment. I will fix it for you.
Yeah.
So he helped us, volunteered, and built this beautiful nose and canopy for the kilojoule. And then we matched it with aluminium. And we didn't get to the very last piece. You can see it's missing under the tail. We just ran out of time, even the next year. Anyway, we had another great team of volunteers that made it the way out to Bonneville. Less of a hike than Lake Gardner, but still quite an effort.
There's the composite guy on the right.
That's Jim Corning. He built the nose. And then Bill, me, and then a few other volunteers helping out. And on my 30th birthday, 29th of August 2011, we set our very first world record. And we thought 222 kilometers per hour was insanely fast, and we were so proud of it.
Yes, we were.
Anyway, we continued, kept coming back year after year to Bonneville, broke into the 300s, added a bit more, got myself a Guinness World Record, which people think is absolutely amazing. The reality is that Guinness World Records are actually kind of an entertainment thing, published by a book publishing company.
Yeah.
But it's, I can't.
Well, right after us, I noticed the next world record was for the world's longest eyebrow. So, it was. Yeah.
But it was great. It was great publicity. And you can see, if you're looking to the right in the picture, that's my old mascot, Bonnie S. Flats. She's a kangaroo. She was the co-pilot for the kilojoule. But unfortunately, I have to say, being on this side of the water, a kangaroo was not acceptable as a co-pilot. So we had to hold an audition and casting, and Dolly, who is the purebred New Zealand merino sheep, she got the new position as Green Envy's co-pilot.
Yeah, fair enough.
But she feels at home right in Australia as well. So
yes.
So she has no problem with the language, I think.
Yes.
400 kilometers per hour was a big day. We've been chasing that for quite a few years.
This gave us the overall the sidecar record.
It did.
Yeah.
Yes, it did. And that was one of my best selfies I've ever taken. You can still see the mark from my head sock on my head.
You have to wear a full flame suit. It's like you're in the middle of the summer in a cabin. It's almost 50 degrees outside, and you have to wear a snowsuit. It's, oh boy.
You have to follow the same safety requirements as the internal combustion vehicles, even if you don't have any fuel on board. And there's no point in even.
Don't even argue. Just do it.
You just do it.
Yeah.
Our all-time best was 270 miles per hour or 434 kilometers per hour. That was not an official world record, but it is a registered top speed.
Right.
And just to kind of get a feel for what it looks inside, that's how I'm crammed inside. And this is actually after we extended the cockpit with 40 centimeters because
it just was too tight.
We tried to build it as tight as possible, and it was a bit too tight. And you can see the sidecar wheel there on the side. And steering wise and handling wise, it drives just like a car.
Okay.
All right, so here's the next technical challenge. We have a video. I have no clue if Zoom will transmit the sound from the video.
We'll see what happens.
We will see what happens.
It's just music, but it's nice dramatic music.
That's good.
This is about 7 years of work condensed to 1.5 minutes. Thank you.
A chill every time I see that. When Eva's on it, the vehicle's going straight and everything, and she's really giving it the power. You can see it showed up this enormous rooster tail behind the vehicle of salt. It just comes flying out the back, and I can say, oh, 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 here we go. You know, right? It's, oh boy. And in the chase vehicle, she takes off, and then she goes over the horizon, and she disappears until 10 minutes later when I catch up at 80 miles an hour.
So the distances are so big on the salt flats, both in Bonneville and in Australia, that you can actually not use normal walkie-talkie radios.
Direct. You have to go through a repeater.
So we have a tower. What is it? 6.
Yeah. Yeah. 8 meters.
8 meter tall tower with a repeater to keep contact between ourselves.
Mm-hmm.
So Bill is kind of saying when you see the chills or like it's going. So I'm probably one of these most weirdest salt racers.
You don't want to give up the record.
So I am incredibly competitive. I grew up with 2 older brothers, and there's no way I would give up the driver's seat to anyone else. But I don't particularly like the record attempts.
It's just like anxiety, you know? Right?
So it's more like just taking a final exam. It's like you've enjoyed all the coursework, you want this degree and the diploma, and you have to take the final exam.
Which is weird.
Which is weird.
Yeah.
But I love the building, I love the design.
Yep.
I love holding the records.
Yes.
But if I could just somehow
put a dummy, put your clone in there.
Maybe Dolly can just go.
To do it next time, yeah.
Can I just ask, what's the power plant in Kilojoule? What drives it?
We will get to that.
Okay,
soon.
good.
Soon.
Right.
I have slides soon.
Yes.
It's electric, of course, battery powered. Just let's try to answer the question. So didn't we save the planet? We did set out to save the planet. So we don't have any statistics to prove that. The planet doesn't look like it's being particularly well saved right now. But the fact that we invited to your meeting says that we are making some waves.
Making some waves.
And hopefully getting some of you inspired of maybe looking at the electric car next time you buy your next car.
Show the next slide.
And we also said we wanted to make headlines, and we did make headlines. And
Lots of headlines over the years.
Here are just a few of the
lots of headlines over the years.
So we think we kind of accomplished what we strived for.
Yes.
And we keep doing it, and we certainly have a whole lot more big plans. So I just kind of want to summarize a little to my second title slides, how to run a large project on a shoestring budget. And I kind of summarize that as if you want to accomplish something really big, you have to start out by dreaming big. We want it to be the fastest, period. But you have to set a goal. You have to set a realistic goal, and you have to give it a date. We had a date, September 2010 is when we were going to go racing. And even if we 4 days before that, I tried to throw in the towel.
No.
Bill said, no, we have a date. We're going.
Yeah.
Then the third line here, maybe I didn't follow. You had to make a slightly pessimistic plan. We thought we were pessimistic. We weren't.
No.
But at least we had a plan. And most importantly, we went into action.
And you don't give up.
And you didn't give up. And that is how you turn your dream
into reality. And it really is. And it's doing something every day on the project.
Mm-hmm.
So we have a rule.
Mm-hmm.
What's our rule?
You at least spend 5 minutes working on the project, and that typically turns into 3 or 4 hours.
5 minutes every day. So what we do, we schedule our time off from projects.
Yes. You don't schedule time to work on the project. You schedule your time off.
So today, we're just not going to go.
We're not going to go today. We need a rest.
But that happens rarely.
Mm-hmm. That does.
Anyway, so that's kind of our strategy for doing things, running projects that really just way beyond us, but pulling it off anyway somehow. So we have a new dream. So you saw on this line that the scale I showed in the beginning, that there's lots of room for improvements and lots of room for records.
Well.
And the world's fastest motorcycle is really what we are after. So that current record is sitting at, I lost it, at 376 miles per hour, which is 605 kilometers per hour. So we set our target to an even 400, which is about 650. So the Green Envy is the vehicle that we think can do this. On paper, it can do 400 miles per hour, but no one races on paper.
Right.
But we didn't take 9 years this time to get into action. So
we started with
this
pipe.
Pipe.
Just pipe.
So 30th of July, 2019.
We bought pipe.
We bought pipe. Well, we sent we sent pipe to the laser cutting company,
which is way cool.
Well, that's maybe another topic for another time. And they took all our pipe, and in 5 minutes they cut.
And with the plans, cut it all up. And notched the pipe. I don't know if you've ever notched a tube. It takes about an hour to do a tube. It did all the tubes faster than we could put them in a cardboard box. 5 minutes, the whole frame.
But I had spent a month during the CAD for that.
Right.
And then about a year of planning before that. Anyway, so in 6 months.
This is what we had.
And 22 days, the Green Envy was ready. If you want to see all the build photos, they are on Facebook. So 25th of February, we loaded it up, sent it off to Australia, ready to race, and then you know the rest of the story, that everything was canceled.
This kind of closed in on us, and we were closer to race, and we kept, okay, we'll do this, we'll do. No, we're not.
We arrived in Adelaide. We actually bumped our flight 1 day earlier, so we could get into Australia before the 14-day self-isolation requirement went into effect. So we made that decision. We were scheduled to leave Monday morning, and then they announced that Monday at midnight, between Sunday and Monday, these new rules were in. So Saturday evening, we decided we're going to leave Sunday morning instead. So we just packed our bags, changed to the flight.
And the vehicle was already here.
That was already there since long. And landed in Adelaide. And then the next day, they announced that the event was canceled. So, oh well. We did our best, and it will race again next year. So a few things about Green Envy. It is, so this photo, I would say, it is the Green Envy. It is the Lake Erie salt flats. But in Australia, but they were not there at the same time.
No.
We took the photo in a
photo magic.
It's a bit of photo magic. It's the photo is taken in an industrial backyard in Adelaide, and then it's overlaid on the shadows from the kilojoule in the background.
A little hint of red behind the rear, next to the sidecar reel, where I think that's a little of the kilojoule showing through.
No, it isn't.
It isn't?
No, it's the kilojoule sidecar.
Oh, okay.
But don't look too close, okay? I'm no expert in Photoshop, but this is enough for convincing people. So the Green Envy is 1,000 horsepower.
1,000 horsepower.
1,000 horsepower. It's all electric, and as we said, built for 650 kilometers per hour. Should have debuted in Australia in March 2020, but that will be 2021 instead, we hope.
Yes. The dedicated among you may come see it. Yeah.
I'm hoping to.
So the goal is to become the world's fastest motorcycle, full stop.
Right, and we have the horsepower, all the calculations show we should be able to do that.
But
if we have to do it.
The difference between theory and practice.
Well,
yeah. And of course, the goal is again to show that electric vehicles aren't slow or boring.
And look at the wheel on the side. Notice that's not a rubber tire. That's interesting, and we'll get to that later.
If anyone is interested, it's on my extra material. So just a few stats, because we all like stats. So in the current configuration of the Green Envy, which is reusing the battery packs and a lot of parts from the kilojoule, its estimated top speed is only about 530 kilometers per hour. But that's really being on a shoestring budget and reusing a lot of parts what we had. And that's about double the top speed of a Tesla anyway, so it's not that shabby. So 0 to 100 kilometers per hour would be about 7 seconds. So it's a half decent family car. But the 0 to 530 kilometers per hour would take about 56 seconds.
Right.
So it's a steady, continuous acceleration. Nothing like a sports car, really. It's more like an airplane. To make a record run like that, it will take about 20 kilowatt hours, which is equivalent of about 2 liters of petrol. And if you calculate its fuel consumption, well, actually, let me do one first. If you were to drive it on 100 kilometers per hour on a flat highway for a day, you will get about 600 kilometers on the charge. And similar to a Tesla, so not at all with the same comfort. But if you were to look at the fuel consumption at this speed, it will be about 0.4 liters per 100 kilometers, or 634 miles per gallon, which is about 6 times a Toyota Prius. So it's incredibly slick and fuel efficient, or energy efficient, which is expected from such a skinny little vehicle. So I know you are all gearheads and tech heads. So we have a few bits and pieces from the inside, which we think you might find interesting. So in electric vehicles of this kind, and this is a quote from Bill, is that it is
a giant cordless drill with wheels. That's really what it is. They're very simple.
So in concept. In concept, they are really simple.
There are very few moving parts, by the way. There aren't all kinds of things. The gasoline or petrol cars have these enormous crews, and it really only takes we only need the pair of us to run it. We take a crew of like 4 or 5 people just to do all the extra sorts of things, but we could run it just with a pair of us. It really, and other,
Amazing.
other gasoline cars or petrol cars, they take our motorcycles. They'll have a team of 12 people. You know, a clutch man, this fuel injection man, and it's just like you get in the computer and you go. It's pretty easy. Yeah. Go ahead.
So looking in, just kind of looking at the inside, everybody likes to know about the battery, of course. And people that are not into electric vehicles think this is, well, I don't know. Let's just talk about the battery. Battery is really the heart of an electric vehicle.
That's where all the horsepower comes from.
And what we're using in the Green Envy is because we are in a shoestring budget. We reuse the battery packs from the kilojoule. So the kilojoule had 2 complete battery packs which could be quick exchanged. And it would take about 20 minutes for us to unload 5 modules of batteries and putting in 5 fully charged modules, perfect temperature, fully charged, and so on. And that allowed us to race under the FIM world record rules for motorcycles, which require that you make a backup run within 2 hours. And at the Salt, we just couldn't solve the logistics of charging and getting back to the starting line within 2 hours. So we did a quick swap of batteries. But we couldn't really defend going to our sponsors and asking for a new battery quite yet.
Right.
So we took these 2 batteries and stuffed them into the Green Envy. And we
Just to show them we can do it.
Yeah, and this was the good starting point. So we have about 20 kilowatt hours, 400 volts, about 250 kilograms all together. If you're into electrics, I'll tell you the configuration is that there's 2 packs and they have 2 cells in parallel, and they look like those space needles that I hold in my hand there. And then 118 of those pairs in series, and each cell is 14 amp hours. And these are lithium-ion iron nanophosphate cells from A123 Systems. You probably never heard of A123 unless you're into RC cars, perhaps. But they make these cells for hybrid vehicles.
In Formula One.
Yes, they do make cells for the cruise systems in Formula One.
Right.
And
Different cells.
They don't even tell us who uses them. It's so secret.
Yeah, and they can't even tell us these days how powerful they are. They make the most powerful cells in the world.
But they're not allowed to tell us
just how powerful they are. And they say they're twice as powerful as you think they are.
But something of the size, this is not really, what we are using is a
hybrid vehicle, yeah.
Medium high power cell suitable for hybrid vehicles. They're most powerful cells. A battery pack of the size of a bar of soap will start a big truck. But you only got 1 shot at it.
Yeah, that's okay.
Because they wouldn't contain that much energy. What's maybe most impressive is that we have raised the same battery pack for 7 years.
And they're fine.
And they're fine. And they also show something about the longevity of modern batteries. So on the inside, this is what a battery pack are. So they are 10 modules, 8 big ones, 2 small on top, and really 2 battery packs next to each other.
And the fire extinguishers are on top.
Fire extinguishers, these are CO2, and they are mostly just window dressing because the rules require us to have an onboard fire extinguisher system. On the inside, there's a module like you see on the left. So what A123 did for us, they stacked these cells and laser welded the tabs together in the configuration we wanted. And then that arrived, I call it an hermit crab without its shell.
Mm-hmm.
And then we had to do all the surrounding the case, install the battery management system, the wiring, and all the parts you see to the right. So it's quite a job to turn that into a rugged battery module.
Battery, yeah.
So motors and inverters. You asked about that. We're getting to that. So we have 2 motors. They're from Avid Evo AFM 240, which is actually a British-made motor.
Yes.
So it's a British.
I shouldn't joke about British anymore.
Now you're in trouble.
Yeah.
We love the Brits.
Yeah, we do.
Yeah. Actually, if we hadn't been for Brexit, we would have maybe moved to the UK.
Yeah.
But we couldn't. My immigration status was too uncertain with Brexit, so we chose New Zealand instead.
Right.
which we're very happy with it. Anyway, we have two motors. You can see them up in the right in the corner. But electrically, there are 4 motors.
Right.
So these are basically two-cylinder electric motors. You can see there's 6 wires going into each housing instead of 3. And that
Each is a 3-phase motor.
so we have 4 3-phase motors connected to 2 shafts. And I'll show you in the next picture how they are chained together. The axial flux permanent magnet motors, they weigh about 80 kilograms each, capable of about 500 horsepower, or a combined 1,000 horsepower. And because there are 4 motors, we decided, because it's the easiest solution, we ran 4. There are the motors that are hidden in there. We ran 4 inverters.
And that takes the DC current from the batteries and then changes it into AC voltage for the motors to use, and a variable frequency because they're variable speed.
And the throttle response is incredibly smooth.
Yeah.
It actually has reverse.
Yeah.
So the electric motor doesn't really care which direction it goes. So I have a flip, just a switch on the side, and I can go in reverse. If I knew how to parallel park, I could parallel park.
Right.
No, I actually know how to parallel park, but I'm not terribly good at it.
We drove it into the trailer yesterday, or last week. So.
Yeah, so the couple of days ago, we needed to get the green envy out of the our workshop and into its sea container because we had a giant delivery coming.
It's heavy.
And it's heavy, and it typically takes 2 people to push it into the container up the little ramp.
Somebody's got to drive.
And someone has to steer. And Bill had 4 weeks ago an engine overhaul himself.
Yeah, I did.
He got a new heart valve.
Yeah, and so I can't push anything, so. Yeah.
Bill was cut open like a chicken and got a new heart valve, and it's now
healing up.
And so it's not allowed to push, and it needs to get into the container. I thought, I'm just going to drive it.
And it went up smooth as silk.
So we drove it maybe at, I don't know, half a kilometer per hour or a kilometer per hour. It just went
creep up there like a forklift. It was great.
It's posted on Facebook if you want to see the video. Anyway, there's the motor to the left with the sprockets. So the 2 motors are chained together, and then there's 2 sprockets on the rear motor, and the other sprocket is chained directly to the rear wheel.
The motor sprocket is bigger than the wheel sprocket. Think about that for a minute. This is geared for almost 400 miles an hour. So the motors are not turning as fast as the rear wheel.
But it's a low RPM motor.
It is.
So the maximum RPM on these motors is about 2,800.
Right.
And at 400 miles per hour, the rear wheel turns about 5,500.
Right.
So is that how you get the increased speed? If you're using the same battery packs and motors as you were in kilojoule, how do you get that increased speed? Is it just purely the gearing?
We have to change the gearing to match the horsepower supplied, because the motors will peak out at the particular horsepower, and it's the speed of the vehicle. So you kind of play around with getting a gearing just right for the mile per hour, because you don't really know how much horsepower the vehicle is going to absorb.
I think also, and maybe the answer to your question is more simple than that. Green Envy has twice the drivetrain as the kilojoule. So the kilojoule had 1 of these motors, Green Envy has 2. So everything is doubled.
Yeah.
Except the miles per hour, which isn't doubled.
Yeah. I can't really hold a little quiz here because you're all muted, but Mike can maybe answer the question. If you want to go twice as fast, how many times more horsepower do you need?
Mike?
Or Gary?
Not the right person to ask, I don't know. I'm sure it's not...
a lot.
Yes.
Don't know.
Go ahead.
8 times.
8 times more. Yeah.
2 to the power, to the raised to the power of 3. So 2 times 2 times 2. If you want to double the speed, you need 8 times the horsepower.
Okay.
Yeah.
Right.
So this is a thirsty beast to go faster. But let's continue.
Well, so I'm looking at the clock and I'm seeing that we have kind of run over our allocated time. What I've come to kind of my last slide of the prepared presentation, and then I have extra material if people have questions. So we have a lot of sponsors that have helped us over the years, and without them, we could absolutely not have done this. There's no chance. People think it's easy to raise sponsorship for racing. No. We concluded if we flip burgers at McDonald's instead of chasing sponsors, we will make about the same amount of money per hour.
It's like convincing your neighbor, getting a sponsor or to give you money is like convincing your neighbor to buy you a big screen TV. Why would I do that? You know? Oh, well, I've got cool friends and they'll come over. Well, how would that benefit me? Well, you get to come over too. What? You know?
Can I just buy the big screen TV and they come to my house?
Oh, don't even think of that.
No, you're not cool enough.
It's awful.
So I will have a very short commercial break here, and you can go to Green Envy Racing and you can get your name on the Green Envy starting at $50 if you like. So that's my commercial break. So we're happy to answer whatever questions there are.
We have like 40 more slides that we can pick from.
Don't tell them that.
Yeah, right. But I mean, we can pick from them as the questions come up.
And I will just show, because we brought this up a little bit, is Y-side per motorcycle, and you can see in the frontal area that's really where you can get a lot of speed for a little money.
Yeah, horsepower costs.
Yeah. Oh yeah, I reckon. Tell us about the key wheels. Yeah, thanks.
There you go. Yes.
Yeah.
So that's kind of what we expected for a question.
Yeah,
So I take that as a question. So the key wheel is an interesting project that we are
all in itself. And the land speed community is fascinated. How's it going? How's it working? Everybody wants to know how the key wheels are going, and they're working.
All right, so let's give a little bit more background. So in land speed racing, the absolutely weakest link is tire.
Click on that link. There it is.
So this is where we originally ran on road racing competition tires, and at 213 miles per hour, whatever that is, kilometers, I'm too tired to calculate, but it was an exciting moment. I was right in the measured mile at Bonneville, and suddenly I hear this pop, 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 pop sound.
And smoke fills the cockpit.
Oh, not smoke, but a little veil of smoke kind of comes into the cockpit.
Never a good thing in an electric car.
No, so, I'm on fire. Okay.
I know it's a common occurrence on British sports cars, older ones.
Been there, done that.
I've owned a few.
Yeah. Your brother had a...
Austin Healey Sprite, 64, I believe.
So you've had this in the family, so you can't say anything. Anyway, it's not a good thing when you're at 230 miles per hour strapped in a soda can. So I just immediately shut off the power, deployed my brake chute, rolled to a stop, jumped out, probably at record speed, and discovered there was nothing wrong with the vehicle.
That you could tell.
That I could tell. And it actually took me until I took it apart. This was the last day second to last day of racing, and we just thought we're calling it quits.
We broke something.
Even if we couldn't find out what. I came home, took apart the vehicle to clean it, and discovered that pieces were missing out of my front tire. Ooh, that was a close call.
And the back tire was equally lumpy.
But hadn't burst yet, but it was just about to burst. So we thought, okay, we have run out of tires, we have to do something about it. So we went onto the commercial market and learned that there weren't many tires to buy.
No.
And we learned that the smallest size is the size for a small car. So to the right is our old normal road racing tire, and to the left are the smallest possible tires that could be obtained within our budget from Goodyear Eagle. They're only about $1,000 a piece or so. A piece.
And then the rims, you have to make rims for them.
Yeah, so we had to adapt car tires to go onto a motorcycle hubs and axles. And we ran those, and they work well, but people have tried them, tested them at speed, say about 300 something miles per hour, these will fly to pieces as well. So I was pondering this, thought, okay, I'm going 300-400 miles per hour in a soda can, and the only thing that really keeps me alive is a little piece of thin rubber filled with air. This is not a really good idea.
When a tire goes, it just it takes the whole vehicle with it often. It bursts, it takes a fender or parts of the fender well with it often, and then you wreck the vehicle and it turns it into a ball of metal with the driver compartment in the center.
Yeah.
And this is not good.
No.
Because the tire comes off in a big chunk. There's 10,000 G's on the tire, so that.
So it's one of the most common causes of accidents are tire blowouts. So I thought, I want to run a non-pneumatic tire. The jet cars are running solid wheels. We should do something similar. So the idea was a non-pneumatic tire, but it has to have rubber grip because we are in a wheel-driven category, and we can't just run on solid wheels like the Bloodhound and the other jet cars. But it had to be a design where the rubber wasn't dependent on adhesion. So basically, the rubber can't just be glued onto the wheel, because it will also overheat and
then fly apart.
And we had a few different designs. I'll take credit for the initial idea of a rubber thread that was mechanically held in place, but it was Bill's idea that can't we just grow rubber hair through the rim?
So
that
it's
was
like a stubble.
What ended up being was the key wheel. And if you look at this wheel, this is actually a solid wheel that has grown rubber hair.
Through
it.
Right.
And then it's secured with a retention band on the inside.
For slow speeds.
So make sure at slow speeds these mats don't get
pushed in. At high speeds, they're pushed against as hard as you couldn't pry them off with a screwdriver. But at slow speeds, the salt can push in
and build up under it, and then they just eventually will fall out.
Right.
And if you look up close, this looks like something that NASA would have put on their Mars rover. But if it was a Mars rover, we'd probably put down a message in Morse code, but we're not, because that would be out of balance. It wouldn't be good. And there it is installed, and there's my own action figure Barbie that I bring out when I meet kids. I have to tell the story about the Barbie. So we were at a big car show last year, and I had my mini Eva action figure with me. And it was a little boy, maybe, 4 or 5 years old. He was looking at this doll, and he was looking at me, he was looking at this doll, and then he said with a firm voice, "Boys can be race car drivers too." And I thought, mission accomplished. So that's kind of where the key wheel idea is. I have a ton of photos from the manufacturing of it.
And it goes on, things go on, but it's actually, we have a good partner in Volcaprin, in the, what company was it? Belgium?
So I made all these pieces myself. I would just quickly flip through the slides. The first wheel we built with a friend of ours, CNC machine in his garage.
We put the holes in.
And I 3D printed the rubber, installed it in a different way, pulling it through. So this was our very first prototype, which worked.
It
worked, but not terribly well, because the rubber didn't really stay in.
It pushes in, the salt pushed in the nubs.
So then the new design was a much more sturdy design. Ran all the finite element analysis to make sure it could actually withstand the speed, despite all these holes. Evaluated rubber, and then what I did, I 3D printed the plug, cast myself a mold. Vent holes was a bad idea, but I thought it was a good idea at the time. And then so that's the rubber mold where the pieces are cast. And then I cast an industrial rubber in the University of Auckland, where I used to work in their lab. And this is something I hope I never have to do again, because it's incredibly difficult if you don't have the right tools or skills.
You have to work at 120 degrees Celsius for all the components.
And you have a pot time of about 2 minutes.
Yeah.
Pot life of 2 minutes. But I made the wheels. We ran them at 236 miles per hour, 380 kilometers per hour last year in Australia.
Yeah.
So it was a success in that we could prove that we could do it. And out of the sky fell another person. Let me do something better for you.
And Volcaprint.
And so what we are a totally open book with everything we do.
Right.
And we post it on social media what we do to everybody's scrutiny.
Yeah.
But Volcaprint is a company in Belgium, and they make the world's fastest roller coaster wheels, polyurethane roller coaster wheels, and they are actually, as we speak, making new rubber inserts for
From
us
Volcaprint.
from their super high-tech, high-performance material.
Yeah, we're very, very excited about that. And he's also making contributions as to the profile of the rubber and things like that, to, you know, for lack of heating, and, you know, it's very, very good to have a polymer expert involved. He's the best in the world. So we're having a good time. Anything else? We have lots of slots.
Bill and Eva, I'm just looking in the chat, and a couple of questions.
All right.
Somebody, I think, is wanting to know how much the vehicle Green Envy will weigh in total, I guess.
Oh, okay. Yeah, I didn't include that.
Yeah,
we're almost embarrassed to answer.
Needs to lose a little weight.
So we were hoping it would come in under 1,000 kilograms. It didn't. It's about 1,200.
Yeah, weight doesn't matter so much in land speed racing. You really have lots of room to accelerate, and weight actually helps you get traction.
So weight gives you traction without induced drag. You can get traction through downforce.
You know, by putting an upside down wing on, which we do.
Which we do. There are several problems with traction through downforce. So weight isn't a huge punishment because it gives you traction, but weight has to be in the correct place. Because I don't know if you've seen, you probably watched the world's fastest Indian
with the cigar.
The cigar.
Right. Yeah.
And your center of gravity must be in front of your center of pressure, which is pretty much the center of your cross-sectional area, of your side area. And so weight.
If it's not, the vehicle will want to spin. It gets a little sideways, and the wind will catch it, and it'll go backwards, and then spin around. And
so weight on the rear wheel gives you traction, but weight on the rear wheel also means that your vehicle wants to go nose first. So you have to have weight in the front to get the weight balance correctly. And also another problem is with motorcycles. Spoilers and wings are actually outlawed. You can only have, what they say, there has to be an integral part of the streamlining.
Right.
And it turns out that the sidecar motorcycle category is a perfect vehicle.
Because it has a sidecar.
It has a sidecar, which is a horizontal platform, which has to have a minimum size to hold a theoretical passenger. And you're allowed to streamline that in any way you want. And we have turned it into a wing that provides about 100 kilograms of downforce. So in the sidecar motorcycle is what we have built is basically a vehicle that is, in reality, for all practical purposes, a car, but it runs in the motorcycle category, and it's allowed a horizontal airfoil, and it's the only horizontal airfoil allowed in the motorcycle category. No other motorcycles can have.
It can't be movable.
So they just showed it. Can you see the screen? Are we showing the screen still?
Yeah, we can see that.
So this is the sidecar fairing, which is actually 3D printed. It's one giant piece of plastics. And we built the 3D printer to make it.
Oh, wow.
So that's a 6-day print on this big printer.
Yep.
Cool.
But that way we could get the exact complex shape we wanted, and the shape is designed in CAD and run through.
Question, Barry. The downforce generated by the wing on the right side, does that cause instability?
It doesn't cause, not really instability, but an asymmetric vehicle is never favorable. It's never really of any benefit to you. The only benefit is that we end up in the motorcycle class, and that was the big benefit, is that we compete against two-wheelers with our 3 wheels.
Also, the Green Envy, you can tilt, in between runs in the pits, you can shim the tail so it will turn like a rudder little bits as you want to keep the vehicle straight. So the tail is actually a separate piece.
So the kilojoule, we weren't really thinking of, we had a whole lot bigger problems to solve when we built the kilojoule. And the way it compensated by itself for the asymmetry is it actually crabbed a little bit. So it never really ran with its nose straight forward.
And you adjust the rear wheel and the sidecar wheel so it would work with the crab.
So it would, under power, if you add throttle, it would still go straight. And if you release throttle, it would still go straight.
We have someone with their hand up for a while here.
KMSGR.
Hello, Eva. Hello, Eva. I love your work. I'm just wondering if you have an endpoint like a commercial adaptation to domestic or industrial use, or are you just not just, but making electrical transport more attractive?
We get this question quite often, right? And the answer is no, we don't really have any really commercial intent. There are people that do the commercial stuff much better than we do. Right. We're always kind of just seen this as a activism. But however,
it's an expensive hobby.
It is an expensive beast, and we have learned a lot of things along the way. So we added some slides just in case we
get this question.
And we would like to change the sign of our cash flow because the Green Envy is an expensive beast to
a hole in which one pours money.
So we are just starting up a business, and what we just bought last week. Yeah. We bought a machine that used to make single-use drinking straws, which
not going to make it anymore.
Which no one wants anymore.
Right.
So we want to make 3D printing filament. So during this process, we have learned a lot about 3D printing. We're getting people excited in 3D printing, and it's a market that's going skyrocketing.
Oh, yeah, wish us luck.
So the commercial side of our lives will be this piece of machinery that we actually brought home yesterday evening.
Yeah.
There it came on the truck. And that's Bill with the biggest smile I've ever seen him have. So the commercial side will be 3D printing stuff, and we're hoping the racing program will help us advertise that.
You asked.
You asked?
Yeah.
And you actually, this is not even public yet.
Not even public. You guys are the first to know.
You will not find it on the Facebook post. More than we have moved out for a big delivery. Yeah. And that's why we had to move the Green Envy out and get it into the container, was because this thing was arriving.
Right. Yeah.
Oh, yeah, that's right.
Barry, was that a question or a comment?
That was purely a comment on how someone turned the ideas of electric into reality.
Yes, but he started with $600 million from selling PayPal. Yeah. We did not.
Yes.
I would sell PayPal, but I don't own PayPal. That's what the issue is. Yeah.
Yes.
Okay. Any more questions? If not, we'll let these good people go, seeing they're 2 hours behind us. Or ahead of us, I should say.
Could I just say something, Mike?
Of course.
I feel it would be appropriate for me to thank Eva and Bill for their time and for agreeing to come and speak to our little club over here in Melbourne. As I said, I've been following them on Facebook and on their website for some months now, and they're always posting something about what they're doing. And that's because they're always doing something. They're always building something, modifying something. Eva's even been out painting the container that they ship Green Envy in. She's been out with a roller, putting a racing stripe around it. So they're incredible. They do fantastic work. And as they said, everything that they do, they post on Facebook. So we can see what's going on.
I'm going to share my screen again here.
Yep,
because
sure.
you brought up they're following our container, and I think can you see our screen?
Yep.
So this is our.
We built this.
Our sea, we have a 20-foot sea container which we own, which has all the which the Green Envy it travels in. It has shelving, it has generator, it has all the equipment for racing in the outbacks.
Like a trailer without wheels.
But it also has a satellite-based GPS tracker that we built.
We built.
And it sends a message every about 6 hours and tells us its position. And then a friend of ours coded that into a website, so it automatically updates on this map. So you could, at map.greenenvyracing.com, you could follow its all the its route to.
And it almost went to the green dot.
Almost, we didn't quite make it to the stop. But
I found it interesting to zoom in and see the circles it does, both obviously in Auckland and also in the Adelaide port area.
Oh yeah, for sure.
You can see all the see all the port calls and everything here.
Yeah.
So it went this route, and then the red one is coming back.
Yeah. And Eva and Bill have made the shelving inside their container. They've made a racking system, mobile racking system for tubs.
I do all of that. Bill doesn't.
Okay, they're sort of top to bottom makers, and so thank you very much, Eva and Bill. We really appreciate your time. If ever.
I hope you found that interesting. I first time I saw it, I thought it was fantastic, and I've actually looked at their Facebook site since then, and of course they're not doing anything at the moment, but it was an interesting exercise, and as I said earlier, thanks to the Sprite Club for finding that and allowing us to record it as well. So our next Zoom meeting will be the general club meeting on the November, first Thursday in November, our usual club time. And that's all from me. And thank you, Gordon, for, yes, Rod.
Well, just rather than go too quickly, I'm gobsmacked. I mean, that is absolutely amazing. While I was watching it, I Googled it, put her name in, and you said you didn't know where she came from. Well, she told us in the end, Sweden. But do you know that she got a pick? This is just so funny. She's running these motorbikes on the salt flats. She got a PhD in corrosion. Can you believe that? In corrosion. And the other thing she's famous is she does 3D handbags, 3D printed handbags. So, I mean, does anyone else feel really lazy and inferior after watching that? That is just, I mean, she's 39. How old do you reckon he is? 50? I don't know. But obviously, no kids. That's the key to this, isn't it? To be no kids. That's much my excuse for why I've wasted my entire life. But that was an incredible story. So, thanks to getting it off the Sprite Club, and thanks for the Sprite Club for chasing it up. But that is just incredible.
Yep. Yeah, well, we've got some interesting stuff we've actually got an interview with Bill Emerson, who you might know is quite a famous Austin Healey person. He lives in Florida, and just this week, Bill Ingham and Bill Metcalf have interviewed him, and Gordon has recorded it, and we'll be able to play that at our general club meeting. Do you want to say anything about him, Gordon? Because I haven't seen it.
No, I think we can just keep that. I mean, well, some people may have seen the book he's written.
Yes.
But he's a man that's a bit like Eva. He's done everything in his life.
Yeah. Yeah, so that should be really interesting as well. As I say, I haven't seen it, but he's,
So, Terry, the other thing I was going to say was that what a couple. I mean, how he backed her up with just 1 and 2 words at a time. Just she was doing all the talking. I mean, no, seriously, I've never seen anything like it. I mean, she was talking and she got the knowledge because she is a mechanical engineer herself, but he was just saying, yeah, right, yeah, and then a few bit more detail. And I don't know anybody else like that, but I just thought that was absolutely amazing. Yeah.
Yeah. Well, he's a mechanical engineer as well.
Yeah.
And how is the history from her family? Her father was a mechanical engineer, her brother.
Well, apparently, when I looked at it, they met because he already had an electric motorbike, and she asked him. Heard of it, came across after she could take some photos of it, and 18 months later they were married. So it's interesting. If you go to Wikipedia and Google it, you get a little bit of it. I can't find anything on him, but I'm going to follow the website and follow them on Facebook because I think that's an incredible story.
Yeah, no, it is good. I hope you've all enjoyed it. And did you say something, Paul, or were you waving your hand? No. Okay. Thanks, everyone, for coming along. And
thanks, Terry.
We'll catch up soon.
Thanks, Gordon. Thank you very much.
Right. Yeah.
No.
Okay.
Bye.
Cheers.